Alright, in this video we're going to take a look at areas of composite figures. Okay, a composite figure is just a figure that we can separate into figures that we know how to find the areas of, like triangles and parallelograms and circles or semicircles. Right, so let's jump right into an example. Okay, here in this one we have a rectangle that is right up against a semicircle. So we need to find the area of each of these two pieces individually and then add them together to find the total area. So let's start with the rectangle. That's pretty straightforward. Right? So the rectangle in red here. So we know that the area of a rectangle is base times height. We have both the base and the height. So the area is going to be 15 times 34, and 15 times 34 is 510. So the area of this rectangle is 510. So now we need to find the area of this semicircle. Well, we know that the area of a whole circle is pi r squared, but this is half of a circle, so I want half of the area of an entire circle. So the area of this piece is going to be 1/2 pi r squared. Well, now we need the radius. So what's the radius here? Well, if I know that this entire side of the rectangle is 15, that's the same as the diameter of this semicircle. So if the diameter is 15, the radius is half of 15, which would be 7.5. So the area is going to be 1/2 times pi times 7.5 squared. 1/2 times pi times 7.5 squared. So if we round to the nearest tenth, that would be 88.4. And then my total area is just going to be these added together. So the area of this composite figure, just add 510 to that, and that should get me 598.4. So my total area here, 598.4. We have units, so square feet. All right, let's try another one. Okay, in this one we have a square butting up against a triangle. So let's do the triangle first. So our area of a triangle is 1/2 base times height. So let's say this is the base, and by these little markings we're told that all four of these sides are the same. Right? So 22, 22, 22. So the base we can say is 22, but now we don't have the height. But what I do know is that if this entire distance from this tip here all the way over here is 42, and this length here is 22, to get the height of the triangle, I can just take 42 minus 22 and get 20. So we end up with 1/2 times 22 times 20. And we end up with 220. So the area of that triangle is 220. Then the area of the square is pretty straightforward. Right? It'll just be 22 times 22. And 22 times 22 is 484. Yeah. So then the total area of this composite figure will be 220 plus 484, which will be 704. And we do have units, so square centimeters. All right. Let's try a couple more. Okay, on this one, it's not already split up for us. Okay, we have to figure out how to split this one up. Okay, and it actually looks like we're going to have to use 3 figures. Okay, so let me draw a dashed line here. So it looks like we can split up right here. Okay, that I'll have a square up here that I can find the area of. And then I can also split right here. So what we end up with is a square, a trapezoid, and half of a circle. Right? So let's find the area of all 3 of those pieces and add them up. So the square, that's easy. Right? That's just base times height. So 13 times 13 is 169. So then, let's do the trapezoid. Do that one in blue. So the area of a trapezoid, we said, was 1/2 times the height times the sum of the 2 bases. So, remember the bases are the 2 parallel sides. So my bases are going to be 13 and 30, and the height is 20. So this will be 1/2 times 20 times 13 plus 30. And we can just plug that whole thing into the calculator. So 0.5 times 20 times 13 plus 30. We get 430 for the area of that trapezoid. And then finally, for this semicircle, so remember the area of a whole circle is pi r squared, so the area of half of a circle is 1/2 pi r squared. So we'll have 1/2 times pi times the radius. So now we're given the diameter is 30, so that means the radius is half of that, so 15. And 1/2 times pi times 15 squared gets me 353.4. And then my total area is just all of those added together. So what do we end up with? Plus 169 plus 430, 952.4. So my composite area, 952.4 square inches. All right. Now, let's take a look at a couple where we are missing a piece. Okay, so here, if I want the area of just this shaded region, the easiest way to do this is going to be to find the area of this entire rectangle and then subtract this half circle. Okay, so what we're going to do first is find the area of the whole rectangle. Okay, so the area there is just base times height. So that'll be 30 times 50, which will be 1500. And then we want to find the area of this semicircle. So the area of that, like we've been saying, half of a circle is 1/2 pi r squared. So the radius, the diameter is 30, so the radius will be 15. I think that's the same semicircle we did in the last problem. Right? So 353.4, we don't have to type that into the calculator again. 353.4. Now, to find the area of just the shaded region, what we are going to do is subtract. So I'm going to take 1500 minus 353.4. So we end up with 1146.6. And that would be square feet. Okay, so on problems like this, we're adding all the different pieces together. But on something like this, where we kind of have a chunk missing, the easiest way to do that is to find the area of the whole figure and then subtract the chunk that's missing. Okay, let's try one more like that. How about something like this, where I just want, so the directions aren't very clear here. It should say find the area of the shaded portion. Okay, so to do that, well, let's first find the area of this entire rectangle, and then subtract the areas of those three circles. So, well, all I'm given is the radius of one of the circles is 5. Well, if the radius is 5, that means that the diameter would be 10, and then each of these circles are congruent. So this entire length of this rectangle would be 10 plus 10 plus 10. That would be 30. And then, well, if a diameter this way is 10, a diameter this way is also 10, which means this side of this rectangle is 10. So the area of this entire figure, base times height, will be 30 times 10, which would just be 300. So now, let's find the area of one of these circles. Well, I know that area of a circle is pi r squared, and I know the radius of one of these circles is 5. So 5 times pi squared. So that will get me 78.539. So now there are 3 of these circles, right? So if I want the area of all 3 of these circles, I'm going to take 3 times this 78.539. So again, in the calculator, I can just do 3 times second ANS down here. So the area of all 3 circles is going to be this 235.619. And then the shaded portion, my final answer, is going to be 300 minus the area of all 3 of those circles. So minus 235.619. And again, in the calculator, we can just do 300 minus second ANS. And that gets me the shaded area is 64 point. Now is when we would round to the nearest tenth when we get our final answer. So 64.4. And our units are square centimeters. Okay. Let's try one more story problem here. Okay, so on this one, it says we've got a botanical garden and there's a koi pond with a walkway around it. So this middle figure is the koi pond, and then this larger figure is the walkway around it. So we want to find the area of the pond and then the area of the walkway. So first, okay, well, we're going to have to split this piece up a little bit. So let's draw in a couple of lines. So what we end up with here for this koi pond, we've got a rectangle in the middle, and then we've got two semicircles on either side. So what we can do is find the area of a rectangle and the area of a circle. I mean, if we have two half circles, that's just going to be the area of one whole circle. So let's do the rectangle first. So area is base times height. So 13 times 7. And I believe that'll be 91 square feet for that part. Then for semicircles, okay, again, we've got two half circles, so that'll just be pi r squared. That'll be one whole circle. So pi times the radius. Well, now we know the diameter is 7, so the radius will be half of that, which will be 3.5. So pi times 3.5 squared. $38.5 if we round to the nearest tenth. And now the total area of the pond will be those two added together. So plus 91, 129.5. So now, to find the area of just the walkway, what we need to do is the same thing that we just did, and then subtract the koi pond out of that. Okay, so I'm going to erase this so that we don't get confused. But let's draw in some lines here to split this up into a rectangle and two semicircles. So this larger rectangle will be base times height, so 35 times 15. So 35 times 15 gets me 525. So the area of that rectangle is 525. And then again, just like we just did, we need to find the areas of these two semicircles. So that will be one whole circle, so pi r squared. And again, the diameter is 15, so the radius is half of that, 7.5. So the area is going to be pi times 7.5 squared, 176.7. So the total area of this whole thing will be 176.7 plus 525. Which gets me, whoops, I hit it twice, 701.7. So, not quite done yet. That's the area of this whole figure. I just want the area of the walkway, which means I still need to subtract the area of the koi pond. So I need to subtract 129.5. So 701.7 minus 129.5 is 572.2. So the actual area of the walkway is 572.2. And that is square feet. All right. So go ahead and upload a picture of your notes to Schoology and try this set of problems on Edge Elastic and send me any questions that you have.